Do you want to start with an introduction?
Yeah, so my name's Rich Bukowski. I'm one of the principals with SSC Engineering. We're here in Chesterfield, Missouri. We've been in business 30 years, and we do mechanical, electrical, plumbing, fire protection, and structural engineering on commercial buildings.
All right, my name is Enrico Reddy, and I'm a senior at Marquette High School. Um, I'm I'm a I'm planning on going into S&T next year for mechanical engineering.
Yeah, good.
My name is Emily Laurie. I'm a junior at Marquette High School. I don't really know where I'm going yet, though.
You got plenty of time.
Hi, my name is Samir Farouk. I am also a junior and also unsure on where I'm going.
Okay.
So could you start with just like a short description of your job?
Yeah, so, back when I first graduated and started, my job was a structural engineer. And then over the years, you learn more about projects and building systems, and you start picking up other aspects of what other people do. Sort of worked my way into being project manager of projects and eventually bought ownership in the company. So I oversee the operations. I manage clients and projects. So I put together the teams, schedule the workload, um, help do and complete the quality control review of our documents, and then work with a client on getting permits and work through the construction with the contractor. And then we do here at SSC, we do all types of buildings. We do schools, we do hospitals, we do labs, we do police stations, we do warehouses, and we're licensed in 48 states. So we do work all across the United States.
So you mentioned that you do like quality review and you look at all the different types of stuff. So would you say that like engineering for you would be not just about designing things, but about like sourcing materials and looking at different ways to like getting patents and stuff like that? Like, is engineering just about designing, or is there like different stuff you have to do before you design things?
Yeah, so engineering as a general, for the work that we do, I would say you probably spend maybe 50% of your time actually engineering things. And I'll pick on mechanical since you have an interest in mechanical, but when they have to determine what they think is the best mechanical system for the building that's going in. And there's a lot of pieces and parts and filtration systems that go into it, efficiency ratings that might be trying to get, different controls, electronic controls that depends on whether or not they want to monitor it and dial things up or down for better use and occupancy. But then those specific engineers will also work directly with the manufacturer and help define products and equipment that meet the criteria that they would like to achieve for their design. And then the rest of their time, I mean, there's going to be a mix of meetings and coordination meetings with other team members. The big part of our job is putting together a set of construction documents or bid documents that a contractor can bid and put a price to, and then ultimately that's what they build our building based off of is, all the documents that we provide for the mechanical design, the electrical design, the plumbing and structural, all of that is put together with an architectural design and then the civil engineer's design to sort of provide everything that's required to get that building up and running, make it safe and comfortable and, efficient and, obviously not have mistakes.
So would you say that like each person has like their own set job and like every single like day or week you guys group up and then you discuss on how to move forward using that same job for each person?
Yeah,
Or does
so
it change around?
no, it varies. So I mean, within the mechanical discipline, there's drafters and designers who have more of an associate's degree. They may not have a bachelor's degree, so they're not technically engineers, but they learn technical backgrounds, both at school and on the job. And then there's the engineer, but then there's an engineer, there's going to be a senior engineer, and then there's a department manager that each play a different role in that. Every week, our team sort of meets, each discipline meets once a week to go over all the projects and to see where everyone's at. And then every week, our project managers meet to go over workload to see, is someone too busy? Is someone too light? Hey, these are our new projects coming up. Who has time to work on these? And really, there's skill sets that you develop with time. So when we do, let's say, labs and healthcare projects, that requires a different experience background because those types of systems, both for electrical and mechanical, are more unique, more healthcare related, special ventilation systems, special cleaners and scrubbers that you wouldn't see on a school or you wouldn't see on a retail building. So there are, over time, with experience, you start developing maybe some specialty skills or knowledge that you've picked up on the job, with time. Does that help?
Yes, thank you.
Okay. So, I don't know, other questions you guys may have. I mean, so the buildings, they can be very simple structures that you can spend, a day working on and issue, an answer to a client, or some of them, could take, a year and a half to 2 years to fully engineer and put it together. And that might be more of a, we've been working on a job down in Disney. It's a high-rise hotel. So it's a really big building. It's over $100 million in construction costs. And the amount of time it takes to get that fully engineered and work out all the systems, it just takes a lot of effort. And then it has to go through permit review. So another engineer that works for the city will review all of our documents, review all of our calculations, and then they make comments to us that we then provide written feedback as to why we did what we did. Should we change anything? Do we need to fix anything? And send it back, and then they, put their permit stamp on it and says, all right, they agree that this building is going to be safe and meets the code requirements, set forth by each state. Each state develops code requirements that are sort of guidelines, to help the engineers make decisions on what they're doing.
So I have another question. So about 2 years ago, in my physics 1 class, I met with a person from who's I think it was someone who's an engineer who specialized in fire hydrants and things of that sort. So they talked to us about like certifications that certain like engineers have to get before they work on specific things. Would you say that certifications are a big part as to like your engineering field? Like, did you have to like ever go like I forgot what the name was, but there was some kind of certification like engineers have to get for that kind of job? Like, did you have to do anything like that?
Yeah, so in our particular engineering industry for building design, you have to get a degree from a 4-year ABET accredited college that might be specific to mechanical, civil, or electrical engineering, let's say. And then you have to take a test. It's an 8-hour test, multiple choice. And what it does is it just tests you on everything that you sort of learned in college. Very, very basic, fundamental type system design. And if you pass that, you become what's known as an engineering and training, an EIT. They also call it an FE, which is a fundamental engineering. The terminology is roughly the same. And then you work underneath a licensed engineer for 4 years. And then after 4 years of experience, you can go sit and take a test, another 8-hour test specific to your field to become licensed in the state. So you can only practice engineering in the state when you are licensed both as a company and individually in that state. So it's just sort of like doctors or lawyers or pharmacists. You have to prove that you're knowledgeable enough and take a test in that state, specific to your background knowledge, and then they give you a seal and a stamp that you use to sign all the documents that you prepare, basically certifying that they're in compliance with any rules and regulations. And then beyond that, there's additional certifications that you can get, whether it's through a local society or professional organization that sort of builds upon your professional licensure. And then, fire protection is also a unique one by itself, that there's actually a specific degree in their ship just to become a fire protection engineer, which is all the sprinklers that are in a building that turn on when there's a fire that you see in your school, every day.
I had another question for you.
Yeah.
Well, what was the transition like from having a primarily engineer position into more of a management style job?
Everyone, including myself, that you ever talk to says they always enjoy when they first started working in school and working on projects. That was the funnest time, the best time. I luckily, I still stay very active in projects, and I do still do some design on a much, lighter load than what a typical engineer would do. Because in school, they don't teach you anything on how to manage people and how to do accounting and how to manage projects. They don't teach you about sales and how to keep a client happy. So there's a lot of lessons to learn. And I see a lot of younger engineers that they graduate college and they instantly want to go into project management and start managing projects and clients, but they really have no working experience or background. And the really good project managers that manage projects and clients really have already built upon their success as an engineer, right? They became very well respected, and people kept coming to them because they did a really good job, and they always wanted to keep coming back to that engineer. And that's really what you build upon as a project manager or managing. You can manage just projects, you can manage, clients, or in my case, managing the office projects and clients. But, there's, getting sort of those fundamentals and background experience, I think is super important, because when someone asks you a question and you don't have the answer, granted, you can always go back to your team, and get the answer, but I think it has more value if you can respond more immediately, to whatever your client specifically is asking you, and you have the answer. But it's harder, it's harder as you go up. There's more hours, more effort, more stress. So if you don't like stress, don't work your way up.
We were wondering about your just like transition from college then to your job, like if it was hard to go from mainly like an educational environment, I guess, to like the actual workplace.
Yeah, it's it was nerve-wracking at first, but it actually was pretty fun. I think the key is to find other people, to work at a place where you think you'll get some good mentorship. Are you going to be working by yourself, or are you going to be working in a team? And ask questions about who is going to help teach you and sort of show you along the way. There's usually a pretty good mix of a mentor, meaning someone that sort of helps answer some of your questions, and then there's going to be a little bit of it you got to figure it out on your own. So your college, some degrees in engineering. In my particular degree, I mean, I used a lot of the classes and coursework that I got out of college. That's not always true for all engineering fields. And, a lot of it you sort of learn on the job. You're going to learn how to do things, and there's a lot of judgment calls that you're going to have to make, and really that'll be built upon experience. But I think getting a good foot, out of the ground at a place that will help sort of get you going a little bit quicker and faster is probably the most ideal situation. What you're going to find out is there's a lot of variations and avenues when you graduate to go. I'm just going to say structural engineering, is a subset of civil engineering, but we design building structures. There's structural engineers that just do bridges. There's structural engineers that just do process plants. There's structural engineers that just do glass glazing systems, buildings. There's structural engineers that just do trusses. And then there's structural engineers that work for vendors or people that install structural systems. So there's a lot of various fingers that you can choose when you graduate. And typically, within your first 3 to 5 years, you sort of want to narrow that focus. If you try something and you realize it's not something that you like or feel that you can do for the next 40 years, you may want to switch and see if there's something else still in the same line of work, that you got your degree in, but maybe in a different aspect of it that you feel more comfortable tackling and working on. Because at the end of the day, I still enjoy what I do, because my background is structural. So you still want to make certain there's reasons why you go to work.
So you talked about narrowing things down in college, so for your future job. So would you say that internships are a crucial part to that in order to see which subsection you want to go into?
Yeah, you definitely need to try to get as many internships as you can. They're going to be tougher when you're, writing, not too many firms are going to want to give you an internship when you're after your freshman year. You might see more opportunities as a sophomore year, but, firms, if you don't have any classes that really pertain to the field of what you're doing, you're really just going to be doing some odds and end things at the internship. But I think if nothing else, it helps you realize that you've been in a work environment, you work with others, and you have sort of just a knowledge of what it's like to work in an office environment, and that you've already accepted the fact that that's what you wanted to do. We do get some students that have not done internships and they work and then they realize that they don't want to be sitting at a desk, 8 hours a day, 5 days a week, which we don't, but 80% of our time is still in an office. And so you just gotta, I think internships help prepare you for understanding what to expect, I guess. And it also teaches you how to deal with other people, because you got to learn to get along, just like you guys probably see with your robotics group. Some people contribute more than others, and you're going to see that in the real work life too, that, everyone's going to have strengths, and other people, you have to see where their strengths at and how they can add value to your team. And then, try to bolster that so that you get a higher participation and more active role with everyone that's helping you on your project. So very similar concept.
What would you say are like the best parts and kind of like the worst parts of your job?
For us, for me, the best part is, when I get to finally see, something that designed get built. That's a very proud feeling, a very good sense of accomplishment. So I always enjoy that part. Dealing with an upset client or dealing with a really bad contractor, is tough, because they'll be yelling at you and some people don't maintain the same level of professionalism that you might have. So you gotta if you get involved with that, you gotta have a little bit of a thicker skin and realize, you come from different backgrounds, and at the end of the day, you have a job to do, and how can I continue to make this project successful, even though someone could be at the other end of the line, yelling at you and probably not saying the best things.
Do you think you could describe what qualities make up a good engineer?
So most engineers are naturally, introvert, they're very private, they're very seclusive. And I think the good engineers are ones that aren't afraid to ask questions. They're okay going up to other people and and making them realize that they're not experts and they're going to ask questions so that they can get an answer and move and progress. Whereas some people tend to sit back, well, I'll just figure it out. I'll figure it out. And, they struggle. And, communication is a big role for everything that we do. How well do you communicate with your other engineers? How do you communicate well with the other disciplines? And, just being very open-minded to that and being sort of outgoing and getting outside your comfort level, getting outside, um, things that typically could potentially hold you back.
Okay, and then I think one of our other questions was just like your experience in college in like a STEM major. Could you describe that, kind of like how it went for you, and if you have any suggestions for anyone else?
Yeah, so college was fun. I mean, I had my funnest times were in college. You got to have fun. So you got to still get out and meet people. The key, I always tell everyone that I ever know that before they go to college, find people to study with. And every class that you have, every class that you do, befriend somebody and form study groups. And because you're going to find some people really just understand stuff and they're going to help you through it, and you're going to understand things on other classes and help them through it. So that was super critical, because some classes, I remember there was classes where I didn't have to do much of anything and I got an A, and then someone else in the class was like, how are you understanding this? That doesn't make any sense to me. And especially those basic core classes, your first 2 years, a lot of it is, you're going to repeat chemistry and physics and some of the math classes, and you'll end up taking, I remember taking the hydraulics and fluid dynamics, and I'm thinking to myself, I'm never going to use this, I don't like it, and I didn't really understand it, and that was where I needed guidance and other people to sort of just talk it through, because at the end of the day, you still got to pass the class to get through it. There's a lot of cramming. I mean, you're going to have to create a lot of stories and memories, out of college. So I think the key though is still, I mean, it's sort of like your last chance to have fun too. So, I think your first year, buckle down, learn how to work within the system, and, make those friendships that you can maintain through college, so that, you get the good grades, but then after that, make certain you still break loose once in a while and enjoy the experience, because, once you graduate, you're going to have to, work hard and really focus on your career, and it's not going to be the same.
So would you say that most of the skills that you use on a day-to-day basis are mainly from self-study rather than college, or would it be like a half and half split?
So I eventually went back. I graduated with a bachelor's, and then I went back and took night classes to get a master's degree. And I learned a lot specific to my field when I was completing my master's degree. So I didn't feel the coursework that I got in college with a bachelor's was super beneficial, to what I needed to do every day. So those tasks I was learning on the job. Once I got that advanced degree, it shed some light on some topics and subjects that I think I needed. I'm not certain that's necessarily true for all disciplines. I mean, it was more true for structural than maybe mechanical or electrical. But I think, it's definitely, I mean, you're going to learn to become, I mean, the focus to be successful in a career is to become be really good at something, right? Become an expert, become a knowledgeable resource, become a trusted advisor that your clients or whoever you're working with wants to go to you and talk to you, and you're the reason why, your projects and your job is successful. So you're just going to learn that on the job, right? I mean, you're going to get more of it out of a job than you'll ever get out of any school or degree. So just keep that in mind, that, I mean, obviously you can't get a job unless you get the degree. And then if there's something that you want to specialize more in later on, I mean, you can always go back to school and try to get it later. for what we do in our line of work, PhDs and that type of stuff really don't mean much. It's not a specialty. That highest level of education is not really required. Once you get to that level, you're specializing in unique parts or solutions, that have a limited use or application. They still have a use and an application, and someone needs to research it and do the engineering behind it. But then we just don't need to deal with it as much on our end. My brother is a mechanical engineer, and he works in the automotive industry, and he designs automotive parts. And he would have never, not really most of any of that he didn't learn in school. It was taught on the job, with years of experience, learning new softwares. A lot of what we do in all of our engineering fields is software based. So you have to learn the tools that the industry uses, and a lot of that's just not taught in school either.
How did you narrow down what college you wanted to go to for engineering?
I think the key is to not sweat over where you go. I don't think it's as important as maybe some people think. It can play, depending on where you get a job afterwards, there might be people that graduated from that university that would be more tempted to hire you. But that's not always true. I think it's, my decision was really, I'm originally from Chicago, and I either had to go to U of I or SIUC, Carbondale, as my choices for engineering if I stayed in state. And if I went out of state, my cost went up. And I ended up paying for my own college. So economics played a big role in my decision to go to Carbondale versus U of I. And I am just as happy with graduating from there as I probably would have been anywhere else. I actually had a job lined up through a professor before I even graduated, that sort of forced me out. I ended up here in St. Louis. And I only thought I'd be in St. Louis for a few years, and I've been here ever since for 24 years. But whether or not you go to a Purdue or S&T or a Mizzou, I think you will get variations in your education without a doubt. But I think the key is just to go there, make the best out of it, get that degree, and then, find really a career, use those 4 years of college to sort of help narrow down your focus and make certain that what you're going into is what you want to do some, the summer internships, which will help shed some light on the specific field. And still, if you got to go an extra year to school and change your major because you realize you don't want to do electrical engineering, then you'll figure that out, make that change, and then get your degree and then start working.
And then yeah. Oh, sorry. You can go.
No, go ahead, Emily.
No, I was just gonna say, like, our last question was probably just gonna be if you had any advice for kids who wanted to get into STEM and engineering.
Yeah, I think it's a good field. I think it's a great field. I've been very happy. I think I never really, when I went into it, I was originally in school to be an architect, and I changed into structural engineering upon the advice of another architect that I did at a career fair. So my advice would be, if you guys ever want to come to our place of work and just see some of the stuff we can do, you can learn a little bit about it that way. Internships will definitely give you some exposure. Your experience that you would have working at a really large company with 5,000 people versus a small company with 15 to 40 people is going to be completely different as well. And then, I spent some time just researching, what I would be doing and trying to get a feel on the types of things that I would be doing, that sort of interest me. but you never know. I mean, one of our engineers that works here was originally an environmental engineer in college. Eventually switched, into civil engineering, had no knowledge of what a structural engineer did. Took this job as just, all right, well, I'm going to try it out and I'm going to do it for a year. And if I don't like it, I'm going to switch back over to something civil, like, roadways or grading or do environmental. And she's ecstatic. She's like, I never knew anything about it. I didn't look into it. She goes, I love it. She goes, I would have bought it. But so sometimes it's okay to not know and even potentially still graduate college and not know 100%, just be proud that you got your degree and know that you still have other avenues to work in and still, be successful and make a good living. So it's hard, but all you can do is try to give yourself as much exposure, either now or when you go into college through internships, or go job shadow someone. Go. Hey, can I call a place? Can I just show up for a half a day and check out your office and see what you do? Most companies will let you do that. You may have to sort of work your way to the right person through HR at a company, but I guarantee you most companies would be thrilled to have someone come in for half a day and they can show you what they do. Because in the end, it's an advanced recruitment for us, to find young engineers that potentially become future employees. So most places will open their doors and show you what they do.
Do you have another question?
No, I'm good. Sorry.
Oh,
Go ahead.
cool. I think that was just all we had then. I don't know. I didn't know.
Yeah.
But hopefully, I didn't scare you guys. Hopefully, you're still interested.
Yeah, it was pretty good information. Thank you very much.
Oh, you're welcome. Anytime.
Mm-hmm.
How's your robot doing? Doing good?
Yep, pretty good. We got through qualifiers, and now we're just redesigning it for state. So, wait, Emily, do you have pictures of it? Yeah, Emily will get it up. But yeah, we're in the process of redesigning the ramp and making it more efficient. So, yeah.
How many points have you guys scored before?
So qualifiers wise, we got fourth in qualifiers out of like 16 teams. We got, I think our average was like 120-ish, I think. And we're aiming
125.
Yeah, 125. And now we're aiming at wait, sorry, what did you say?
How many is that points? What is 120?
Yeah, points.
Okay.
And then with the redesigns, we should be able to get around 180. 180 to 200 around there. So that's where we're aiming at.
Okay. Because we had a different robotics team in here and they were explaining, some of the system. I think you guys have to shoot a disc at like 3 different price things and then you got to move on the floor to get points that way too, right?
Yeah. And then there's like an autonomous period. Samir's a programmer. So he programmed the autonomous to kind of go towards and shoot the rings into the goals. So that's a robot right there.
Okay.
That's the one before the redesign. And it has the ramps. So we had a bunch of 3D printed ramps. So one in the front, one in the back. So the golden one is the front one, which uses to shoot out the rings. That's like a 30-degree angle. So it shoots out the rings perfectly in a high goal. In the back, there's a black ramp that you see in the bottom left picture. And it has 2 sets of flywheels that put up the rings into the robot, into a cavity on the golden ramp. And they can stack 3, and then there's a servo kicker, which is just a servo that kicks 1 ring at a time into the green flywheel to shoot it out of the robot.
Oh, so you could put 3 of them in there at once?
Yeah.
Oh, wow. Okay.
So now it's just so sometimes the rings get stuck in the robot. So we're just redesigning the ramps a little bit so it can better fit them and make it more efficient, because that's the biggest problem. And then we're working on like sensor stuff that Samir can explain that, but yeah.
Yes, so during the autonomous period, what we have to do is we have to sense the stack of rings or lack of rings that are on the field, and it's preset with like dice beforehand. And what we have to do is, depending on the number of rings or lack of thereof rings, we have to move this wobbly goal, which kind of looks like a plunger, but it's just wobbly. We have to
Okay.
move it to a certain spot on the field depending on how many rings are stacked on there.
And does it have to do that autonomously, or do you control it?
Mhm.
Oh,
It
wow.
has to do that autonomously.
Wow.
So yeah, and after that, I think the last set of sensors we're planning on doing is like a gyroscope thing. The robot knows where it is on the field at any single point of time, and then you can just click a button during the driver control period to just get it to a certain point that we preset. So that's the last thing that we're working on.
Yeah, it sounds like I always heard that the programming part's pretty hard too. I mean, I know the build isn't easy
Yeah.
either, but
Mhm.
getting someone knowledgeable to learn the programming and always seems to be very time consuming and a lot of redos, I'm sure.
Yeah, definitely.
Okay.
There's a lot of testing that goes into it.
Yeah. You must be pretty good if you're only a sophomore and doing all that programming on that robot.
Oh, I'm a junior.
Junior, okay. Did you start programming when you were a freshman then?
Sophomore year. I wasn't in robotics in my freshman year.
Okay.
Yeah, but Samir started the programming last year. Like he was one of the only people. I think he was the only person programming last year. Or no, so
Wow.
Sam was. Yeah, Sam and yeah. So they're, but Samir's like the main, like the head programmer. I'm the main build person on the team. So
Cool. Yeah, I mean, make sure you guys put all that stuff on your resumes too. You know, if you're a
Yeah.
graduate. I mean, it's
yeah, I definitely put it on my college stuff. So
yeah,
it worked out.
yeah. We have a lot of S&T grads here, so
Mhm. All right. Well, thank you very much.
you guys are welcome. Thanks for
Yep.
reaching out. I appreciate it.
Mhm.
Thank you. Bye-bye.
Thank
All
you.
right, you guys.